Today we're going to talk about multiplying fractions. Now, I was doing a lesson the other day and I was showing multiplying two fractions, and I realized I'd never really explained that before. So I decided to make a video to better explain why we multiply fractions the way that we do. Let's first off take a look at 1/2, which is probably the simplest fraction you can imagine. Now, the way 1/2 works is we have one part to 2 parts whole. So we have a piece of a block. The block holds 2 basically, and we have one of those. So 1 is the blue and 2 is the orange. Alright, so one piece out of 2. Okay, so let's see what happens when we take the 1/2, 1 out of 2, and multiply it by 2. Well, actually what ends up happening is instead of having one piece, we now have 2 pieces. So if we want to count that over here, there's one piece and there's the second piece. We still have, we can use orange since that's what's the original, we still have 2 total pieces, right? But we've increased the parts. We've increased 2 of the purple, right? So there's kind of the medium step as far as multiplying fractions. So now I want to take it one step further. We're still going to have the 1/2, and we're still going to multiply by 2, so we actually have 2 pieces to the whole, but we're going to divide by 3. Okay, so in other words, what we're doing is we're multiplying by 2/3. So what actually ends up happening with 3 on the bottom, 2 times 3 gives us 6, and now we have, let's use red here, 1, 2, 3, 4, 5, 6 total pieces. And we can think of this whole giant thing as one big block, right? So there's 6 squares that make up the block now, not just 2 that we had before. And so in gist, what's happening is when we multiply a fraction by a fraction, and actually let me erase some of this because it looks kind of confusing. When we say we take 1/2 and multiply by 2/3, the 1 times 2 gives you the parts. Okay, so we have 2 parts here, and the 2 times 3 gives you the total. Okay, so as far as this example goes, we have 2 blocks, which is our parts. That's going to be our purple. Okay, and that's our top number. And basically 2 blocks filled in out of 6 total blocks. And the way we got that was we multiplied the denominators. So you basically, in gist, you multiply the numerators to get your number of pieces, and you multiply the denominators to get your total number. Let's look at another example. And again, we could kind of call that parts to whole. Let's look at 1/4. Okay, so we have 1 part to 4 total. And the way we would do that is just this picture on the left, right? We have 1 blue piece out of 4 total. Okay, now let's take that and multiply it by 2 like we did before. What ends up happening is now we have 2 parts to 4 total. We have 4 purple squares and 4 total squares, 2 of them not filled in. And if we take 1/4 and multiply that by 2/3, well, we still have 2 parts, but the 4 times 3 gives us 12 total parts now. And that's why we have 12 total blocks. And it's pretty simple. And I know that simplifies to 1 out of 6, but I'm just illustrating why when you multiply 2 fractions, we get what we get. The numerator gives you the parts, and the denominator gives you the whole. Okay, let's do another one. If we have 2, and then on the top, and we have 5 on the bottom, what does that look like? Well, that means we have 2 pieces filled in to 5 total pieces. Okay, and let's take it a step further. Let's take the 2/5 and multiply by 3. So what happens is now we have 1, 2, 3, 4, 5, 6, because 2 times 3 gives you 6. 6 pieces filled in. This is called an improper fraction. We have more pieces than we do whole number of pieces. We have more pieces filled in than we actually have spaces to fill in. And that's okay. That actually happens quite a bit. You could have 6/5 cups of milk. That would mean 1 1/5, right? You'd have a little bit more than a cup. And just basically, in this case, yeah, that's what happens. So in this case, we keep the number, when we have 2/3 times 3, we keep the same number of squares that make up the block. Now, let's take it a step further like we have before. Let's, instead of multiplying 2/5 times 3, we're now going to do 2/5 times 3/4. So now the denominators multiply, and now we have 20 total parts. And guess what? The fact remains we only have 6 filled in. 1, 2, 3, 4, 5, 6. And so you can see, again, why this happens the way it does. When you multiply fractions, the numerators get multiplied. Okay, and that gave you 6 on top. And that gives you the parts filled in, or the pieces, or parts. And then you multiply the denominators to get the whole. Right, just like you could imagine as a glass of water, right? 6 out of 20 of the glass of water is filled, which I know simplifies to 3/10. So it'd be less than half, right? So same concept, part to whole. You multiply the numerators to get the part filled in, and the denominator to get you the total parts. Now, not always is it part to whole when we're talking about fractions. For example, kilometers per hour, that's not really part to whole, that's separate units entirely. And I wanted to show you how that works. Let's take 4/5, right? So let's say 4 represents the number of triangles, and 5 represents the number of circles. Now let's take the same 4/5 and multiply by 2. Well, 4 times 2 gives you 8, so guess what? Now you have 8 triangles. Now that doesn't affect how many circles you still have 5. But if we take 4/5 and multiply by 2/3, 5 times 3 gives you what? 15. So now on top of the fact that you did the 4 times 2, which gave you 8 triangles, you now have 15 circles. And again, like I mentioned before, you're probably not going to see that. I wrote some of that off of the page here. Where can I write 15? Well, anyway, this 15 gives you the number of circles. Let's just try to meander through here. Like I said before, with a lot of fractions like kilometers per hour, you could have 8 kilometers per 15 hours, which would be really, really slow. Or 8 kilometers per 15 seconds. How about that? That'd be really, really fast. 8 kilometers per 15 minutes. There you go. So it's not always part to whole. The point is, you multiply the numerators to get the units on the numerator, and you multiply the denominators to get to the units on the denominator. It's actually really simple. When I first thought about this, I thought it was kind of complicated until I realized how simple it was. And so in other words, A times C, when you have two fractions, and I actually wrote this in the reverse order. I wrote it incorrectly. Let me pause this and fix this real quick. Okay, so when you take a fraction a over b and multiply by c over d, so here's your a over b, and you multiply by c over d, all you do is you multiply the numerators together, ac, and then you multiply the denominators together, bd. It's that simple. So again, you have your parts on the top. For the most part, that's what a fraction is. And your whole on the bottom. For the most part, but let me erase that because like we said before, your units could be different. So in other cases, you have units on top and units on bottom like we had in this example, your triangles and your circles. Okay, let's go ahead and look at some official examples. 4/5 times -3/2. Now, the point of this lesson isn't so much to cross cancel and stuff, all that works, was just to show you why we multiply the way we do, and also to look at variables and how to multiply those. First step that you're going to do is you're actually just going to multiply straight across. So 4/5 times -3/2, all we're actually doing is multiplying the numerators and multiplying the denominators. The second step is to simplify. Okay, now I didn't do this the short way, I did this the long way. In another example, we're going to do it the short way. But if we multiply 4 times -3, we get -12, and 5 times 2 gives us 10. And simplify means to make short as possible, so we need to reduce that fraction by dividing the top and bottom by 2, and we end up with -6/5. And therefore, the answer to our question is none other than, whoops, I messed up there, is none other than -6/5. So again, you multiply and then you simplify. Let's look at another example. How about a over 3 times 2 over b? Now this one's actually going to be a little bit simpler because we don't have to reduce. So we're just going to multiply the numerators and then multiply the denominators. And then remember that the constant always goes first, so a times 2 just gives us 2a. And then 3 times b, the constant's already first, so we just remove the multiplication sign. So the final answer is 2a over 3b, which is exactly what we were trying to solve to begin with. Let's look at another example. X over y times a over b. We want to simplify that and make it as short as possible. Step 1, we're going to multiply. So multiply the numerators together, multiply the denominators together. You can also look at it this way. You have x times a, which gives you the top, and y times b, which gives you the bottom. And like I've said before, it just looks better if we group these alphabetically. So we have ax on top and by on the bottom, and that's our answer. That's what's going to go inside the box. So it's real simple. You just simplify and then you multiply. Alright, next up we have pi over 2 times r over 4, something you definitely might see in like a related rates problem or something in calculus. This looks real familiar. Okay, again we're going to multiply the numerators, so pi times r for the top, and then multiply the denominators, 2 times 4 on the bottom. Now pi times r just gives you pi r, and then 2 times 4 gives you 8. Therefore, the simplest answer is pi r divided by 8. Alright, let's look at yet another one. We have 1 over x times y over 5. Again, the first step is going to be to multiply the numerators and the denominators, so 1 times y on top and x times 5 on the bottom. Now we know 1 times anything is that thing, so 1 times y is y, and then x times 5. Move the constant out front and remove the multiplication sign. Therefore, the final answer is y over 5x. Great. Alright, let's keep going. This one I wanted to kind of show you, yes, you can use shortcuts and that's fine. It's still the same steps though. Still going to multiply and then simplify. 7/3 times 6 over 7. Let's go ahead, multiply the numerators, 7 times 6, and then multiply the denominators, 3 times 7. Now the shortcut here I'm going to show you is you can, yes, if you have the same number on top and bottom, you can cancel them. And then once you do that, you can then start just dividing. So what's 6 divided by 3? It's just 2. So therefore, for this particular example, we end up with a whole number. And I completely bunked that up. The answer should be 2, so I'll fix that later. Glad I caught that. So 2 is what goes inside the box. Okay, let's take a look at the next example. We have mn over rs times x over -10. The reason I did this one, which I do quite often, is it doesn't matter how complicated the expressions are on the top and bottom, you still just multiply straight across to get your parts over your whole in most cases. So, first of all, we're going to have mn times x, which gives you the top, and then rs times -10, which gives you the bottom. And then, of course, mn times x just gives you mnx. And then we're going to take the -10 and move it out front here because the constant always goes out front to give you that. And the final step is whenever you have a negative on the bottom, you move it to the front, okay, which we've talked about in another lesson. So therefore your final answer is negative mnx over 10rs. So it's just showing you that no matter how complicated or involved the math expression is, you ultimately just multiply the tops and bottoms and then simplify, just like we always have done. So again, this lesson is simply titled Multiplying Fractions, and what you do is you multiply the numerators together and then simplify, and then multiply the denominators and simplify those as well. Or actually, you multiply the numerators and denominators and then you simplify, and you end up with AC divided by BD.